Okay, moving on to the last little bit of our review here. So my graph probably doesn't look like yours, and you'll see that on number 2 here, because, well, I don't have the actual paper with me, and I had to draw it on. Anyway, I don't have a copy of it with me right now, but the principles still apply the same, and so we're going to take this graph and still answer the questions as if we're going to use this graph here. Well, is this graph increasing, decreasing, or constant? Well, it's going up as you go from left to right, so it's increasing. Okay, does the graph have an increase and decrease or constant rate of change? The rate of change is the slope. Over here, my slope's pretty shallow, like 0. Over here, my slope is positive, something like positive 2 or 3. If you go from 0 to 2, that is an increase. So my rate of change is increasing. You notice it's getting steeper and steeper in the positive direction, so it's increasing. The positive interval is listing for what x values is this function above the x-axis, as in the y values are positive. Well, it starts right here, okay, at this point here, and that's the x value of 2. So you're going to put 2 down first, and it keeps going on forever to the right, being positive, so it's going to be 2 to infinity. You know, use your parentheses to do interval notation. The negative interval, well, it's negative all the way up until 2. So from negative infinity up until 2, it's going to be negative. And again, you're writing down for what x values. So for what left to right numbers is it above the x-axis or below. Moving on to 2. End behavior. Please be careful with this as x goes to negative infinity. That means go left as far as you could possibly go. And what is the function value? How tall is this function? How far up and down is the function when you've gone left forever? Well, if you go left forever, this guy is going to go up and up forever, making it positive infinity. Notice it's going up as you go left. And then moving on to the next one, as x goes to positive infinity, so as you go right forever. What is the function value? Well, this is an exponential, and exponentials have some number that's not going to go below, and it's looking like it's this one here, and that is the y value of negative 2. So, and behavior on that side is going to be negative 2. Planting a 6-inch philodendron, and it grows 10% every week when you're doing percent growth. Remember, always start with 100, add your extra percent, which is extra 10%. You're looking at 110%, and then convert it to a decimal. To do that, divide by 100, which gives you 1.10. And now you have what you're going to multiply by every time. Here at week 0, it hasn't grown any, so it's starting out 6 times that by 1.1 gives you 6.6 times that by 1.1 is going to give you 7.26 times that by 1.1 is going to give you 7.986 times that by 1.1 it's going to give you 8.7846. That's a 4. And then times that by 1.1 is going to give you the grand total of 9.66306. Okay, so yeah, you're getting some pretty long decimals here, but yeah, don't worry about it. There you go, you got your beautiful function, and now you can graph it. You notice here, it's not like the typical graph, it's just first quadrant, it's kind of like the full coordinate graph. Well, I'm just going to count by 3's here, just to make it a little bit easier for myself to fit it on there. And I'm going to still count by 1's on my x-axis though, so I can try to fit it all on there. So I got 0, 6 first, 0, 6, and I got 1, 6.6, 1, 6.6, which is about there. And then my next one, 2, 7.26, 2, whoops, my 6.6 is way too high. I forgot I was counting by 3's. More like that. And then 7.26 is really close to like halfway up. And I got 3, 7.986, that's really close to 8. Climbing up. And then my next one is 8.78, that's really close to 9. So it's like right below. And then my next one I have 9.6, which is going to be up a little bit like that. So it is a quadratic. It's just not growing very quickly. But there you go. And then our last two questions: determine the next three terms. Well, this is just got a pattern of adding 8 every time. So if you want the next one, you have to add 8. That gives you 27. And then 8 to that. That gives you 35. Add 8 to that. That's going to give you 43. I think that's right. Yeah, it looks good. And if you're adding the same number every time, it's arithmetic. On this one, it's multiplying by 3 every time. If you really get scared by the fraction, realize it's only for one of them. And you can just look at the other 3 to figure out the terms in sequence. So 9 times 3 gives you 27, times 3 gives you 81, times 3 gives you 243, I believe. 81 times 3. 243, awesome. And you're multiplying each time, so it's geometric. And there we go. What a lovely, lovely review.